Hello students, today we'll talk about predictor corrector methods. In the last lecture we have discussed modified Euler's method, which is one of the predictor corrector method. So in this we'll be talking about Milne's method. First of all, let us see what is predictor corrector method. Predictor corrector method refers to a family of schemes for solving ordinary differential equations using two formulae, that is one for the predictor method and the other one is for the corrector one. The technique of refining an initially crude estimate of yi by the means of a more accurate formula is known as the predictor corrector method. In the single step methods, we solve the differential equation over an interval. Only the value of y at the beginning of the interval was required. But in the predictor corrector methods, we need more values, like we need four past values are required for finding the values of y at a particular x. Though it is slightly complex, these methods have the advantage of giving an estimate of error from successive approximations to yi. So, other two methods are Milne's method and Adams-Bashford method. In this lecture, we'll be talking about the Milne's method. Milne method is also known as Milne-Simpson's method. It is widely used multiple step method and it needs four values, xi minus 3 comma y minus 3, xi minus 2 comma y minus 2, xi minus 1 comma y minus 1 and xi yi to compute yi plus 1. Now, whatever we have done in the previous lectures were single step method like Taylor series, Picard's, Euler's method, RK method, where only one value was required, one base value was required to find out the next approximation. But in the multi-step methods, we require either one or two or maybe four to find out the uh, next approximation. So these values, as you can see, these four values are known as the starting values of this method. If they are not given, then we can find out using the Taylor series, Euler series or Picard's method, like the other single step methods. So consider the IVP, dy by dx is equal to f of xy, such that y at x naught is equal to y naught. Now the predictor formula to find the next approximation of y4 is given by this formula. We always denote the predicted value with the y4 at p. So p is always in the bracket. This denotes that this is the predicted value of the approximation, which is equal to y naught plus 4 times h by 3 multiplied by 2f1 minus f2 plus 2 of f3. Now what is f1, f2, f3? These are the function values that we have calculated at the point that are given to us. Now when we have calculated this predicted value of y4, we will obtain the functional value at this point, which is given by f4 at p. So that would be the predicted f4. Now a better value of y4 is found using the corrector formula, which is denoted by y4 at c. So in the above you can see it is written c. It is given by y2 plus h by 3 f2 plus 4 times f3 plus the predicted value of f4. Now you will notice one thing, that we are calculating y4 with the four past values, that is y0, y1, y2 and y3. So we have four values, so we are using them. Now the improved value of f4 is computed again and the corrector is applied to find a still better value of y4. Now how much we have to correct this value? We will be doing that until and unless we'll get our modulus of the corrected and the predicted value less than epsilon. If their absolute value is greater than epsilon, then we take the predicted value to be as our corrected value and calculate the new corrected value using the above relation. So once we have found out our y4 and f4, we could find the next value approximation of y5, that is x0 plus 5h, which is found from the predictor method, which is given by y5 at p, and the corrector method, that is y5 at c. So this method is repeated again and again for y6, y7, and you can find out the predicted and the corrected values accordingly. So this was our Milne's predictor and corrector method. Let us see one question of Milne's method. Given dy by dx is equal to 1 plus y square, with the initial conditions y at 0 is equal to 0, and we are given the other three values as well. So you will see here I have made a table of x and y's that is given to us, x0, x1, x2, x3 as 0, 0.0, 0, 0.2, 0, 0.4, 0, 0.6, and the corresponding yi's which is given in the question. So we have to find here y at 0.8. So first of all, what is given to us? The h is 0.2. So y at 0.8 is nothing but y4, and f of xy is given to be 1 plus y square. So in this table, I have already calculated the f0. F0 would be f of x0 comma y0. F1 would be f of x1 comma y1. So you just have to fill all the values in the f of xy, and you can make this table and found your f0, f1, f2 and f3. Now, after you have find all these value, it is very easy to just fill the values in the formula. So using the Milne's predictor formula, I'll calculate the predicted value of y4. So the predicted value of y4 using the formula would be y0 plus 4 times h by 3. In the brackets, it is 2 times f1 minus f2 plus 2 times f3. So it is coming out to be 1.02384. Now, the f of 4 at this predicted value is calculated to be 2.048248. Now, the corrected value of y4 is given by the formula y2 plus h by 3 times f of 2 plus 4 times f3 plus the predicted f4. When I put all the values, I am getting my corrected value of y4 as 1.02940. So now I will find that is the it is should I move ahead with the next corrected value, or is it the corrected value? Now if we take epsilon to be 0.001, then the modulus of the y4 corrected value minus the y4 predicted value is coming out to be 0.00556, which is greater than my epsilon, that is the error value that I have taken. So that means I have to correct it one more time. So जब आपको इसको अगेन करेक्ट करना है, तो आपकी प्रिडिक्टेड वैल्यू क्या होगी, जो आपकी अभी करेक्टेड वैल्यू ऊपर आपने कैलकुलेट करी थी. सो करेक्टेड वैल्यू वाज 1.02940, उसको हमने ले लिया प्रिडिक्टेड. अब उसका जो फंक्शन पे वैल्यू आपने कैलकुलेट किया था वो आपका f4 हो जाएगा प्रिडिक्टेड पे. सो आपको क्या फाइंड आउट करना है, सिर्फ और सिर्फ अब आपको करेक्टेड वैल्यू फाइंड आउट करनी है. तो आपको y4 एट सी का जो फॉर्मूला है वही अप्लाई करना है, जिसमें ओनली एंड ओनली व्हाट विल चेंज, आपका f4 इज चेंजिंग. बाकी की टर्म्स आपकी सेम रहेंगी, y2 भी सेम रहेगा, f2 f3 सब सेम रहेंगे. द ओनली थिंग दैट इज चेंजिंग वुड बी योर f4. जब आप उसको सब्सटीट्यूट करेंगे और कैलकुलेट करेंगे, यू आर गेटिंग इट एज 1.03016. Now when I subtract my new predicted and the new corrected value, I am getting the modulus as 0.00076, which is obviously less than my error, that is 0.001. So this would be my corrected value of 0.8. So this is how we could calculate our approximation, the corrected approximations of y using Milne's Simpson method. In the next method, we'll talk about Adams-Bashford method. Thank you so much.